Hey guys, it's Miss Howard, and today we're talking about Pythagorean Theorem. Pythagorean Theorem is a formula that shows the relationship between the sides of any right triangle. Okay, that formula is a squared plus b squared equals c squared. You'll notice on the right triangle, A and B are the legs that form your right angle. C is always your hypotenuse, which is the longest leg of or the longest side of that right triangle. It's also the side that's opposite the right angle. Okay, so C is always your hypotenuse. Okay. So now let's take a look at a model of Pythagorean theorem and kind of understanding this formula.
Okay, so for this right triangle, what we're going to do is build a square off each side. Each square has a side length that's equal to the side of that triangle. When we take the area of a squared, the purple one, and add it to the area of b squared, which is the green one, we will get the sum of these two is equal to the area of c squared. And so there's just one proof of why a squared plus b squared equals c squared. This is true for any triangle as long as we maintain the right angle. So we can change or vary the length of the different sides of the triangle, and Pythagorean theorem will still be true as long as you maintain that right angle. A squared plus b squared equals c squared. Some of you need numbers to show that proof, so here we go.
Alright, so here I have a right triangle. Off of each side, I've drawn a square that corresponds with the length of that side of the triangle. So here I've got a square where side A has to be 3 units long. Okay? If I look at the area of the square that's formed here, well, the area is going to be the side squared, or 3 squared, which equals 9. Okay? So A squared here was 3 squared, which equals 9. When I look at side B, well, the triangle, or the square that's formed off that side is 4. And so if I want the area of this square, I would do 4 squared, or 4 times 4, which gives me 16. So for b squared, I have 4 squared, which equals 16. Okay? When I add these two areas together, when I add the area of these two squares together, 9 plus 16 equals 25. Well, if we take a look at that, this side of the triangle would be a square formed that is 5 squared, or 5 times 5, which gives us 25. Okay. And so that's just a little bit of the background of why this formula works. If we made a square off each side of that right triangle, the areas of those squares would equal the area of the square that's formed off the hypotenuse. Let's go ahead and apply that in some problems. Alright, so here's our first example. We have a right triangle where we're given sides A and B, and we're looking for C, the hypotenuse. So we want you all to get in the habit of always start with whatever formula you're using. So I've already written my formula for Pythagorean theorem. You'll go ahead and write that down. A squared plus b squared equals c squared. And let's just plug in the numbers that we have. We've got that one of our sides is 24. So I'm going to plug that in for A. So I'll need to do 24 squared. I've got my other leg is 32 feet. And so I'll plug that in for B. And so I'll need to do 32 squared. And I'm looking for C. And so I'll leave that variable there. C squared is what I'm looking for. Okay? And so now let's do the math. 24 squared means 24 times 24, which is 576. 32 squared means 32 times 32, which is 1024. And we're still trying to find c squared. Okay? Combine our like terms here, so we've got two constants that we can just add together there. 576 plus 1024 is 1600. Okay. And I hope you don't get confused here. There's no way that this length, or this side, is 1,600 feet, okay? So 1,600 is c squared. Well, we need to get just c. So we'll need to take the square root of this number. So we'll need to take the square root of 1,600 to get side c. Okay, remember when you're looking for square root, you're looking for what number times itself will give you 1,600. And in this case, that would be 40. So the length of side C would be 40 feet. Okay. Let's go ahead and try example 2 together. All right, so in our second example, we are given A, we don't have B, and we're given the hypotenuse. So we want to make sure we plug these numbers into the correct place in the formula. Make sure you start by writing down the formula for Pythagorean Theorem. Okay? And so we've got side A, which is 15. So 15 squared here. Okay. We do not have B, so I'm going to leave the variable B there. Okay. And then I'm given C, or our hypotenuse is 20. So we'll replace C with 20, and that needs to be squared. Okay? And so now we'll just go ahead and solve the equation that we've got here. So 15 squared, 15 times 15 is 225. We still don't know B yet. And we can go ahead and solve 20 squared. 20 times 20 is 400. Okay. From here, we're trying to isolate our variable here, so we need to get rid of this positive 225. We can do that by subtracting 225. And remember, whatever you do to one side of the equation, you have to do the same thing to the other side. So we're going to subtract 225 from each side. Okay. 225 minus 225 is 0, so we're left with b squared on the left side of the equation. On the right side, 400 minus 225 is 175. Okay. Again, remember, we're not at b yet. We're at b squared, and so the way we find b is by taking the square root of 175. Now you'll notice 175 is not a perfect square, so you've got to estimate, and usually you'll be given, do you need to estimate to the nearest whole number, to the nearest tenth of a number, or whatever it may be. So if I take a look at that, I know that 175 is between the perfect squares of 13 and 14. So I need to estimate around 13 point something, okay? And so you can do the math. You can try 13.2 squared. So you can do 13.2 times 13.2. You can estimate, if that's not good enough, 13.3 squared, and see which one gets you closest to 175. Okay? For this one, I've already done the math, and the square root of 175 is about 13 and 2/10. So our missing side here, A, would be 13 and 2/10 centimeters. Okay? If you'll do now, just go ahead and pause the video, try example number 3 on your own. Alright, so in the example you were just given, you were given side A, or excuse me, you were not given side A, you were given side B and the hypotenuse side C, okay? And so we've got A squared plus B squared, which is the 15, so 15 squared, okay, equals C squared, which is the 25 squared. Remember, C is always your hypotenuse, so hopefully you put the 25 as replacing the C, okay? And so you'll just do your work here. 15 squared is 225. 25 squared is 625. We're trying to isolate the A, get it by itself, so we need to get rid of this 225 by subtracting. And whatever we do on one side of the equation, we do the same to the other. Okay? And so 225 minus 225 is 0, so just A squared left here. When we subtract on this side, we get 400. Remember, this side is not 400. We need to take the square root to get down to A. And so then the square root of 400 is 20. And so our missing side, A, is 20 inches. Okay? Remember, guys, if there's anything you weren't sure on, feel free to go back, rewind, pause, take this at your own pace. Come ready to class tomorrow to work on Pythagorean Theorem. Bye.
Gentlemen, if I were to place this mallet in this position, what would it form?
Right angle.
Right. And now?
A right triangle.
Absolutely wizard once again.
The square of the hypotenuse of a right triangle is equal to the sum of the squares of the two adjacent sides. Eureka! The square of the hypotenuse of a right triangle is equal to the sum of the squares of the two adjacent sides. Now that we've come this far, men, let's go through the rules again. Parallel lines never connect, which is just about what you might expect. Though scientific laws may change and decimals can be moved, the following is constant and has yet to be disproved. The square of the hypotenuse of a right triangle is equal to the sum of the squares, not less, not more, as I said before, is equal to the sum of the squares of the two adjacent